Hello and welcome back to the Ultimate AWS Hands-On course. In this video, we will learn about what is RDS and DynamoDB and what is the difference between the two. Then we will do some hands-on and create a table. Make sure to hit the subscribe button if you haven't already. Now let's get started. So, in the world of databases, there are two main characters. 1. Relational databases, also known as SQL. 2. Non-relational databases, also known as NoSQL. Let's quickly understand the basic difference between relational and non-relational databases. In relational databases, data is stored in the form of tables, similar to an Excel sheet, where a column defines an attribute, and an item is inserted row-wise. A non-relational database stores data in a non-tabular form. It uses a storage model optimized for specific requirements of the type of data being stored. These store data in different types, like key-value pair-based, document-based, graph-based, etc. Often combinations of these types are used for a single application. Some of the popular SQL-based databases are MySQL, Postgres, Oracle. Some commonly used non-relational databases are MongoDB, RDS, Cassandra. This was about relational and non-relational databases. AWS offers services for both types of databases. RDS for SQL databases, and DynamoDB for NoSQL databases. Let's first talk about RDS. RDS, or Relational Database Service, is an SQL database service. You can select from different options provided, like MySQL, Postgres, Oracle. On the other hand, DynamoDB is a NoSQL database service. And unlike RDS, DynamoDB doesn't provide any options. This is the only option for all of your NoSQL needs. Okay. Now let's do some hands-on. Here we are, on the AWS dashboard. Search for DynamoDB. In the left panel, click on Tables. Here you can see all of your tables. Let's create a new one. Giving a name to the table, say My Table. Next comes the partition key. A partition key is a fundamental concept that determines how data is distributed and organized in the database. In the easiest terms, you can think of a partition key as a way to group and store related data together. To understand this concept, imagine you have a large collection of books. Each book has a unique identifier, such as an ISBN. Now, you want to organize these books in such a way that the retrieval of a book is easy. How would you do that? One way is to group them based on their genre. For example, all the mystery books are placed together, all the science fiction books are grouped, and so on. And within each partition, books can be sorted as per their publication year. In this way, if you want to find a book, you only need to look in the partition of the required genre, and even in that partition, books are sorted as per publication year, so, you can apply binary search to find the book quickly. In this analogy, the unique identifier, ISBN number, is similar to the primary key in DynamoDB, and the genre is similar to the partition key. The partition key determines which partition, or group, the data belongs to, and helps distribute the data across multiple servers to achieve scalability and performance. Within each partition, the books are sorted based on their publication year, which acts as the sort key. This enables efficient retrieval of books published within a specific range of years. Let's give ID as partition key. We can leave the sort key as it is optional, but you can give whatever you want to. Now, down here, we can either choose the default settings or customize settings as per our needs. Default settings are typically designed to be user-friendly and require minimal configuration. They can be suitable if you are new to the system or service and prefer a simplified setup process. They are often optimized for common use cases and offer a good starting point for many scenarios. If your use case has unique requirements that cannot be adequately addressed by default settings, you can customize them as per your needs. Let's go ahead with the default settings. Click on Create Table. This might take some time to be up and running. Here we go. Our database is ready. That's it for this video, folks. In the upcoming video, we will access this table from our Lambda function and perform CRUD operations on it. See you in the next video. Until then, happy cloud computing. Don't forget to like and subscribe.